Hello and welcome everyone to today's webinar, Protect Your APIs with Microsoft Azure Sentinel and 42Crunch. I'm going to hand over to Colin momentarily, but for those of you who follow 42Crunch closely, you'll have noticed that we've recently become members of MISA, and on foot of that, we thought this webinar was very apt. So fasten your seatbelts and I'll hand you over to Colin.
Thanks very much, Hugh. Welcome everybody joining today's webinar. So just an introduction to myself. I run the API Security.io newsletter. I'm the Chief Technology Evangelist at 42Crunch. So what we're going to do in today's session, it's somewhat of a recap. We hosted a similar event with a guest from Cyberproof in 2022. We looked at monitoring APIs. So, APIs, as we know, increasingly under threat, and it's pretty important that you are proactively monitoring and protecting your APIs. Now, there's a number of different approaches to this in the market. We can talk about, the pros and cons of these when we do the wrap up at the end. But the way we think about this as a philosophy is use the most appropriate protection technology and then feed those logs to your existing logging agents rather than reinventing a separate logging solution. So we're going to be talking about mostly threat hunting and SIMs and SOCs, and it's all around the Microsoft Sentinel platform. Okay, so, and just to set the scene, APIs are now the top attack vector. I actually kept that slide from the previous webinar. And it's interesting to see how much in only 6 months, how much more prevalent API attacks are. There's two big stories in the news at the moment, a US telco and a big US social media platform that have both had massive breaches relating to APIs, right? So they're increasingly coming under attack. This is well documented. Intrinsically, it makes sense that this is an issue. What's threatening your APIs? So just bearing in mind some of the attacks that we're seeing. So, who's attacking your APIs? So we've got all sorts of attacks, and I think we're seeing these. We're seeing, script kiddies, low technical ability, folk who just downloading scripts and running, Nikto or something against APIs and seeing what they can do. Scrapers and bots. So this is becoming an industry. People are able to go and subscribe and buy access to bot farms to access a particular API. If you look at the volumes of data that are being exfiltrated, it's in the hundreds of millions of records, right? So these are very massively distributed, highly leveraged attacks, right? So it's not just some chap having a hack at your API. It's being done on an industrial scale. And then the really advanced people, the hackers, the people who are using advanced techniques to get at your APIs. And then we've got the problem of the fact that your inventory, your API inventory, obviously you've got a growing number of APIs. We've all seen the reports on that, but it's actually the type of APIs. So shadow APIs, these are APIs that exist in your organization that you don't know about. I mean, these are pretty much the most dangerous. And one of the big recent breaches was exactly an exploit of a shadow API, right? It was the case of an internal API that got switched. They decided to make it public and somebody forgot about it. Zombie APIs, these are legacy or outdated APIs that people have left running. Misconfigured APIs, insecure defaults, exposing unnecessary endpoints, all of that. Frankenstein APIs, these are ones where the business goes and develops them in some backhanded manner. They use shadow IT, they go and run up something on a GCP instance, and they don't have the standard controls. So lots of threats to APIs, and this is above and beyond the OWASP API security top 10, and we all know enough about how severe some of those issues are. So these are really things about how can people misuse and abuse your APIs. Yeah, and to that point, so the type of API attacks we're seeing, these are all things that I would classify pretty much as abuse cases. So the bot attacks are trying to find APIs, enumeration, denial of service, distributed by large botnets, credential stuffing attacks, account takeover attacks. An API is a really good place to go and try and take over an account. because the endpoints are exposed, and that can all be scripted and automated. And then API scraping and pagination. So this is, let me give you an example here. This is, let's say, for instance, a shopping website that's listing their inventory online. Instead of doing the normal behavior where you just go and look at the latest, I don't know, shoe trainer prices, what you're able to do, what an attacker can do is they can go and paginate through that entire inventory and mine all that data, and then they build themselves a price list, and then they rig their pricing to match, so they're just coming in under a competitor. And this happened on the real estate market. The airlines always used to be having a go at each other, exfiltrating their pricing. So we've got 2 polling questions, easy ones today. Okay, so haven't got the ad. So I would have thought the most common would be via log monitoring. Good to see people who answered some. We'll come back to that in a moment. The fact that 1/3 of people aren't monitoring is possibly cause for concern. So, stand by. That's really what we're going to be talking about, the importance of doing that monitoring. So just a history on our approach now. The fact that we're talking about SIM and SOC and an API monitoring solution might seem odd to folk who know the company, because we consider the shift left API security company. Right, those are very standard DevSecOps or shift left benefits. The advantages of being able to catch security issues or any quality issues earlier in the life cycle typically means you reduce the cost of deployment and rework. You have reduced risk exposure. Developers become more aware of these issues, right? They become more the security issues become more ingrained in their thinking and their design, and obviously you secure it by design. So I think the industry is sort of converging on, there's some difference of opinion of what DevSecOps is, but that people are generally coming around to the benefits of doing this via shift left. Having said that, it has challenges, right? So it is relatively reliant on a standard or established DevOps process. If you are running a very ad hoc development process, shifting left can be very tricky because you can't easily reproduce builds, right? So that's one of the concerns. Legacy systems that just weren't built with shift left in mind. The Shadow and Frankenstein APIs, this is where your business units are doing things to get to a time to market, and they're just putting stuff out there, come, hell or high water. They're doing it by whatever means. There's no point in shifting left if you don't even know who these people are in the first instance. Third-party and partner APIs, where you're buying in APIs that doesn't necessarily suit, you don't have control over that process. And people who just building APIs, they haven't started using open API specifications, right? So let's be honest, there are challenges to shift left. It's not it's a great approach, but it comes with its own issues. So what do we propose to do about this? So protecting at runtime with shield right. So shift left, shield right, I think is pretty much our manifesto. And what we do is we offer an API specific a micro firewall that's really designed to work well with APIs. And just technically what it is, it's a reverse proxy. It sits in front of your API. It protects your API according to your open API specification. So it enforces that contract. If something isn't in the contract, it's blocked. It's really designed for cloud native deployments. It's got things like supports a service mesh and Kubernetes injection. It's highly optimized for performance and footprint. It's tiny. It operates in millisecond latencies, and it can do other things like rate limiting, security header validation, and JOT token validation. We'll have a look at the overall picture. So we've got this combination of a shift left and a shield right. So we cover, the API security lifecycle right through that 8-phase SDLC. Right. So now onto the topic of the webinar. It is pretty hands-on. We're gonna get quite practical. We're gonna have a good look at learning Sentinel. I'm hoping most people aren't particularly, aware of Sentinel at this stage. Because hopefully this is going to be valuable to a really quick view of what Sentinel does. So Sentinel is Microsoft. It used to be called Azure Sentinel. It's their cloud-based SIM. It's creating great interest in the market, shall we say. Obviously there's a big value add for people who are already using the Azure stack or using Office 365 range of products, and they can easily integrate, both of those sources into Microsoft Sentinel and get all that intelligence. So just to remind people, if they're not familiar, SIM is a security incident and event monitoring platform. Think of it as a centralized logging platform where all of your emitters from your infrastructure get centrally aggregated, right? And basically the idea of Sentinel is it's meant to, so it has a built-in AI platform, but its real sort of claim to fame is it's able to analyze large volumes of data, and it's able to do that fast. Now, the volumes of data I'm talking about, I've worked in organizations that are generating many, many terabytes of data per day, right? So we're talking super high volumes of data built into the Microsoft and Office platforms, integrates pretty seamlessly. We talk about it's able to ingest data. It can ingest anything that's on those platforms with little or no sort of overhead. Integrates with third-party components, and really this is what this webinar is about. It's the fact that we've built our own integration. So what I showed last year, in the middle of last year, is I showed a very quick proof of concept, really testing out the idea, and based on the interest that we've seen from partners, customers, and the market, we've gone out and we've turned this into an offering. So it's available in the marketplace, and we look at that in a second. It uses the log analytics data source as the underlying platform, and obviously you get the benefit from Microsoft's expertise and just their capability in the AI ML space. And then as part of this, we've also joined the Microsoft MISA, Microsoft Intelligence Security Association. Think of this as a members club for everybody who's working in relating to intelligence and security, Microsoft partners and Microsoft integrators. We're the only API security company in that space, and we're very pleased that we've been able to get this accreditation based on the work that we've been doing around Sentinel. The 42Crunch Sentinel integration. So we're going to have a look at this at the moment. If you've got access to Sentinel, or you just go and Google Azure Sentinel Marketplace, you can go and have a look at this, what this is. And I'm going to take you through the installation so you just see what it does. It's a connector, and now what the connector does is it's able to ingest logs from our firewall. It's able to then ingest those into the platform, and we can also run playbooks. Think of a playbook as a query or a rule. It's a little bit of called KQL. It's their query language, Microsoft's query language. It looks a lot like SQL, and it allows you to query that data and build your queries on top of that. So let's talk. We come now to that question too. So we're going to go into the demo in a moment. So if folk could just answer this question. So those 29 odd or 30% who are using a SIM integration, do you know what SIM you're using? If you could just pop through answers on that, one or more of those. Okay, so thanks for that. Right, Splunk is the leader. I would have probably guessed that. And good to see Sentinel. So a third of you are going to find the next section really interesting. Those that haven't seen Sentinel, just stand by. We'll have a look in great detail. So that's where we're going to go on the next slide. Talk about doing the live demo. So before I go to the demo itself, I just want to explain the infrastructure so that you can understand what's happening here. So I've got the highlighter marked. So I've got an API In this demo, in this webinar, I'm using the HTTP bin API app, and that's just it's like a loopback API. Anything you send it sends back, and I've got that. I'm protecting that with the 42Crunch micro firewall. In this case, it's just deployed as a container, as a reverse proxy sat in front of the HTTP bin instance. And then I've got our log forwarder, which is the Azure integration that we've got that's able to monitor the logs from the firewall, push those out to log analytics, and then we'll be able to see them coming into Sentinel. And then I've got that exposed. We'll do a bit of digging around on that API and see what it does. So I think what I'm going to do at this point, so let me cover the next two slides. So what we did is we've had these APIs, we've had endpoints exposed on the, we've had the APIs exposed on the internet. And what I've done is I've just gone and garnered information over 6 months, just for curiosity, to have a look what's actually happening to these APIs, right? It's effectively an API honeypot. If you've got anything in a public Azure IP address range, you get probed almost immediately. I'm sure people are aware of that. It happens almost immediately. And I went and had a look at, because with the firewall, I can actually capture the paths, right? So we're seeing here loads of things trying to access. So what are we doing here? We're looking for PHP, right? We're looking for PHP myadmin or SQL admin. And that's pretty obvious that people would do that. They're looking for hidden login forms and the like. So really interesting to see what we found. So people looking for .env files, environment files, lots of PHP, looking for git config, looking for hidden AWS secrets, trying to execute shells, directory enumeration, run a trawl through the directory structure, looking for well-known JavaScript files, and also trying to log in at standard login locations. The more interesting thing, and this is where we get an idea of the level of skill that these bots are leveraging, is, these are at the time, so this is dated now, it's 6 months out of date, but what we were seeing is we were looking at 0 days that had been recently disclosed. So there were a couple there. There's one on a Laravel framework, the PHP framework. There's one on an Apache project, and there's one on a fiber router. And we actually found symptoms of, in amongst that trail of directory accesses and file accesses, things that were very, so here's an example. We found people trying to access that URL, which meant that they were trying to attack this this vulnerability, right? So even though the exploits were pretty recent, there were already attacks in the markets, in the wild against these. All right, so it's an interesting data point that these things become commoditized and they get out into the wild pretty quickly. Right, so that's where we're going to break at a moment. So I'm going to answer those two questions. So can 42Crunch be integrated with the SecuCon sim? Yeah, that was one I didn't put in that list. The answer is yes and no. Not at the moment, but yes, it's relatively easy to do. That log forwarder that we're going to have there will be changed to, well, it can be changed to support other formats, things like Kef and syslog. That's a relatively easy thing to do. So if there's demand for something like that, that can be done. So not at the moment, but definitely not beyond the will of man. And the other question is, how do you force the APIs to go through the micro firewall, right? So that's an easy one to answer. I'm just going to kick back to that demo. So what we have here is the firewall sits in, when I say sits in front, it's basically it's a reverse proxy, right? It's exactly the way Nginx or Ingress Controller or Load Balancer would work. So your app will run on port 8080, and you'll just expose that. So the API firewall takes two parameters. It takes the host, the the public interface and a port number, and then it reflects that traffic through to the back end. So you normally just put these on port 8080 and you expose the API on port 80 in the front. So I hope that answers the question. Works exactly the same. In fact, it is using the Nginx engine. So works exactly like a reverse proxy. Right. What I'll do now is I'm going to switch to Sentinel. So I'm going to give you the very basic Sentinel guide. So what we're doing here, we're looking at the Microsoft platform. So this is Azure. I'm going to get that hidden now. This is Sentinel. This is like a dashboard view. So imagine you're a security risk operations manager and you want a quick overview of what's happening in your organization. You fire this up. You can see what open incidents you have. You can see there's some incidents that have come in the last 24 hours that was getting ready for this webinar. It's the single pane of glass risk view. So that's what Sentinel looks like. We've got logs. I'm not going to go into that at the moment because we will look at that in much greater detail. Yep, that's fine. Incidents. So as you'd expect on a risk dashboard, you've got open incidents, closed incidents, and the severity rating to these incidents. And what we provide is with the integration that we've put out into that marketplace, we provide 11 sample analytics rules. Now, an analytics rule is a little playbook that runs. So we'll go and have a look at the playbooks. You can see we've got one that comes with Microsoft that's already enabled, but we have our 11 different playbooks. We'll take a good look at one of those in a second. But what we can do here, and this is where I'm going to show the Microsoft, our integration, is this is a marketplace. There are 278 different solutions by providers. And if you go and have a look through the type of people we've got in here, we've got Akamai, we've got AWS, we've got Apache, we've got Apache Tomcat. So if you're using one of those hosting services or one of those products, you can integrate Jira, Slack, Auth0. Most big players will integrate into Sentinel. And of course, 42Crunch, right up at the top. And if I go and look at those details, so this will tell you what you need to be able to, you need to have access to our firewall. You can, you can watch further details on this. But what I'm going to do now, I'm not going to click right through the way, but I'm going to show you the experience that you have when you, and what this is actually doing. So as standard, you'd have to create a subscription, a group. We'll just do that quickly. Now the data connectors, the data connector is the thing that is connecting to our firewall and pushing the data into Log Analytics. We also provide workbooks. We'll have a visual look at a workbook in a moment. We provide 11 analytics rules, as I've said. So there's details on those. What it's doing is it's just running through a little validation to check that this is going to work. And we are ready to go. So if I hit create, that would go and install that. But as I said, I'm not going to do that at this point. We'll come back to Sentinel. So if I am going quickly over this, if people do want to stop and take a deeper dive or a closer look at something, please by all means do shout. I'm aware I do, because I've been very familiar with this, so I might be making assumptions. So if you want to have a look at things, shout. We go and have a look. What I'll do is I'm going to talk to you what the data connector looks like, because there was a question on how do we connect this thing. So if I go to 42Crunch, right, we'll have a look now that the data connector, I've only got one connected. I've got 42Crunch running. What that is seeing is, let's just get a nicer view for you on that. So we're seeing here that we've had the last log was received 40 minutes ago. That sort of makes sense. I did one 10 minutes before the start. We can see it thinks it's connected, which is good. And we can see now we've got the data. So we can see we've had a flurry of data today. That's obviously setting up for this webinar. We can go and have a look at the underlying let's just do this. And this is the KQL syntax that I was talking about. And I can make that 5 minutes. So basically what this is saying is, show me every log entry where the prove that it is live. We'll run that. So right, 55 minutes. So we should find some data here. Yeah. So what this is saying is, show me log entries where the time generated is greater than 55 minutes. Right. So that's things beyond 55 minutes. If we go and have a look at things that are generated more recently, we're not going to find anything there, because obviously I've been talking to you and not running not running any queries. Okay, so that's what the logs look like. And what I'll do is just see which one that is. So what I'll do now, just close that query. So that's the raw log view. So that's what's coming from the connector. Just get that connector page up again. We come with instructions. You've got to get things like, you've got to get your workspace ID. This is all log analytics stuff, and a key. And it's just run with Docker Compose, really easy to run. Okay, so that's the connector. We've done all that heavy lifting for you, right? You don't have to go and do anything significant there. And then we come with these the 11 built-in rules. So let's look at a simple rule. So what I'm going to do now is I'm going to juggle back, and there's going to be a bit of back and forwards here. I can work out the best way to do this. So the first scenario is, a common one, an account takeover, right? So how does somebody take over an account? So typically the sequence is, it depends a little bit on the back end, if it's OAuth 2 or whatever it is, but they will try to register with a fake email. They will try to force a password reset, and then trying to brute force that. They'll try and guess the reset codes. Be aware of these websites or APIs that take like a 4-digit reset code, right? That's easily guessable. And then they just brute force that, right? So how would you detect this? And that's just a simple strategy that I put together, right? So detect access to sensitive API endpoints, so you know what your reset register endpoints are, and look for lots of 403s, so lots of access denied, right? So that's the simple algorithm for how you would go, and we could make it more sophisticated, but that would probably work. Now what I'm going to do is I'm going to generate synthetic data in here, and I'm doing that just so I can show you as it comes in. So that's that, and I'm going to run that now. So what this will do, it's going to push that data up to the platform. You can see that's attempting to brute force that reset endpoint. Right, and then we'll go back to Sentinel. And what I'm going to do is I'm going to go and look at the logs. That away. Okay, let me just expand that out. So here's an instance where we have the log data. There's a lot of system information in here. That's my fictitious application name. That's the Firewall instance that's running. Source IP address. That's in this case is fictitious, but that'll be the source IP address and port mappings. Be the host name, and the interesting ones here are the API reset. So that's the path that API that the attacker attempted to call with a post. The status, the response code was a 403 that came back, right? And then we'll see we've got a load of those. You could see all those whizzing past. So we can see them in the raw logs. Now let's go and have a look what those look like in Sentinel. And I'll come back to, not that one. that one. Let's go and have a look at the analytics. Right, and the one we looked at was API 1, the first scenario. There, account takeover, and we will go and have a good look at this. So here's where you can set your techniques. So if people are familiar with the MITRE framework, an attempt to take over an account would be credential access, and yeah, that's all I've put, credential access, and somewhere there, if we can stop scrolling like that, discovery. So they're trying to guess and find accounts, and we've called that high. I think that's pretty much, would agree on that. That's a high severity. Now here's where this gets interesting, is that's the query. Now I'll have a better look at that in a second, but just imagine for a moment there's a query that's running against that that thing, and what that is doing is that is mapping us out data. So what we can see, we've just got the one that's come through right now. That's the one that you literally saw me generate. And here's some earlier. I think what I'm going to do is I'm going to blow this up into, and I will make this bigger because I know it can be difficult to see. So this isn't a tutorial on KQL, but just to give you an idea what this is doing. It's doing the query. It's getting rid of some fields. It's looking for things that are that came in 5 minutes ago. It's getting rid of some extraneous columns that it doesn't want. Then it says, look for me where the path is API/register or has API reset, and where the status code is 403. Right. And then it says, if I see 20 of those, so this, this fantastic expression here is basically doing a count and saying if the count is greater than 20 in the last 5 minutes, then return a value, right? So what's the logic there? If it hits API reset, it hits API register, and it's done more than more than 20 of those in the last 5 minutes, then flag that event, right? And we've got one instance, and I can prove to you, I'm sure you believe me, API reset 403, right? So the rule logic, it's writing KQL is never pretty, but don't worry, we've done that all for you, right? The other thing you need to have a look at in this, I'll just make that screen a little bit more compact. The firewall can identify a number of entities. We had a look at those things like source IP address, the host name, the instance name. Now, in the Sentinel world, they have their own entity mappings. So what they allow you to do is a bridging, an entity mapping over here. And what we do here is we're saying where we see source IP address, bind that to Sentinel's IP, same with host name and the like. And that's the basics of a rule. That's a relatively simple rule. People have a full-time job of writing KQL rules. It's a pretty well paid job as well. So you can sit and write these rules. Once you have an event that triggers like that, then you have you create an incident. And what I'm going to do is I'm going to have a look at what an incident looks like. So an incident, think of a working definition of an incident is something that requires action, right? Somebody needs to have a look at this. Obviously, you've got these thousands of records flying into your log analytics. No analyst is going to be looking at all of those. So what you have to do is you're using queries and using some of the AI and ML to go and create incidents. So here we go. So we've identified incident ID 19, and here's where you have, you can assign this to people. You can set the status, so you can mark it as false positive. You can adjust all of the parameters, right? This is things that your SIM and SOC, your security operations center, would use, right? But you can see what's happened here. By being able to map that information in, right, Sentinel is now aware, right? It's become aware that these fields mean something. We've also got those MITRE techniques. So we could, for instance, now go and have a look at everything that is a credential access. And here we have, so the IP address. Now, if I click that, I think it's going to, new features. Right, so it can then allow you to say, hey, is this IP address, what is he doing? So we can see here in this case, we've only done one thing. We can do queries. So the idea is that you can just start drilling in, finding more detail, right? So when you get the initial trigger of that incident, because remember, these attackers aren't just doing, they're not doing one thing. They're probably doing a multitude of attacks. So you can really click into that and find out what they're doing. Do you have any other instances of account takeover attempts? Right, so that's the incident view. Pretty powerful on that. And I'm just seeing they have changed. I'll go back to the old experience because I knew that a bit better. Yeah, so you've got the entities, you've got your MITRE, and you've got the similar incidents. You can also go and have a look. At this point, you could make a playbook. Now, a playbook is, okay, so we don't have that permission. A playbook allows you to go and do that investigation and all the threat hunting. That's beyond the scope of what we're looking at here. But yeah, you could start now writing playbooks for that.
There's a question there.
Yes, I see. So do the rules automatically appear in dashboard? Yes. So let me talk through that because that's a good point. So we've written those rules. We give them to you for free. They come in the analytics panel and they import it as templates. Now, you can see here what else I've got. There's loads of these. So this is coming from gallery content, and this is saying we noticed here using the 42Crunch protection. So we give you those, and what you've got to do is you just open that, and you can tweak the rule. If you don't like the rule, you can change it slightly, and then you create a rule from that. Right. So, and then we go to active rules. So that does answer the question. I'm sure. Yes, we give you those. Those are already enabled. Just mindful of time because I want to take questions on this. Let's look at going to look at a couple other rules because I think the rules are probably the most instructive if people can cope with the. Okay. Make that a little bigger. And which one am I on now? I'm on 8. So what I'm going to do is I'm going to show you that here we have no data. And what I'll do is I'm going to cheat and I'm going to make some data now. I'm just doing this as a quick short hack to avoid having to actually go and run Postman and do things in that because it's pretty intense. So we'll run this. So that came through quickly. Now that doesn't always happen. The demo gods are on my side for once. It can take up to 5 minutes for that to process and come through. Right. So we found that we've got that. Let me just see if I can change any of the parameters on that. What was the? No, I can't. Right. So that's the one I just generated now. So there we've got it coming up in the raw KQL, and we can test with current data and we should ping. There we go. Right. That's the one we've just seen. Open incidents. What's the time now? 3:51. So that one probably hasn't come through. That's the most recent one that we had. Just remember that we've got 2 at the moment. You'll see that will refresh. Okay. So, analytics, I'm just wondering any other rules. So, Kite Runner. So Kite Runner is another scenario. So if people have not used Kite Runner is a API endpoint discovery, content discovery tool. It's a bit of a Swiss Army knife of attacking APIs. It really just does a brute force and tries to enumerate your API endpoints, paths, content, you name it. It'll just run through and do an analysis and see what it can find. Sorry. So let's just go and run Kite Runner now. right, and card runner is there. Okay, so, and it's open source tool. If you're attacking APIs, it's the one that I'd recommend that you go and use. So what this is doing is it's doing a small dictionary attack. I'm using the small dictionary, and it's just busy going and thrashing away at the at that API. I'm not going to wait while that comes in, but what I'll do is I'll go back to Sentinel now, and I'll do logs, and let's get rid of that. I'll do everything that has come in the last. No, you see, Cartrun has actually found an endpoint. This is interesting as well. So it's discovered a valid endpoint, UUID. So if I go to if I go and query that, if I just do an HTTP and I query an IP address, there's an IP address, and if I ask Cardrunner to give, if I ask HTTP bin to give me a UUID, it obliges. Right, so what Cardrunner has done there, that's pretty important to see, is actually found that UUID endpoint, right? And you can see by the length of time it's running, it's absolutely thrashing that API with data at the moment. You know, not a KQL tutorial, giving you enough information on what Sentinel does and how it works and the type of things that you can do. As I said, those queries are available. We've also got the integration is available in GitHub as well, and there's lots of samples in there, and of course also you know, how you can adapt this to other log formats. Just coming back to Sentinel. While I'm on Sentinel, so the question here is from Julia: how do you get the data from Kubernetes into the log analytics workspace? It's that slide. The firewall is emitting logs to a volume mount, and the log forwarder is just sitting in and pushing those to log analytics. What I've done there, but yeah, the idea is it's just taking the logs that are written in our sort of standard format, and then converting those to log analytics tables, and then using I think there's an open source log analytics integration. It's all written in .NET Core, and it just pushes those into log analytics and does the mapping. So relatively simple piece of tech, and that is on our public Git as well. Yeah, so I think that answers that question. What I want to do now is, leaving time for questions, I just want to summarize what we've looked at. So the good news is there's no more KQL, which is a relief. Yeah, it can do things like suspicious logins. So Sentinel obviously knows which IP addresses it's seen, right? So if you find an IP address that you've never seen before, you can mark that. So it's not an incident, but it's just something like, does this make sense, right? Are you suddenly getting access from somebody somewhere you haven't seen before? Rate limiting, first-time access, job validation, right? So what are the use cases and benefits, and why do we at 42Crunch think that this is quite a unique proposition? So, you know, other things that you can do is, obviously you can do all of that IP address mapping. You can do geolocations. You can do threat intelligence using Microsoft's own threat intelligence feeds, or if you're subscribing to a paid service, you can pull that information in. And I'm going to have good timing on that question, because I'll answer it in the section. The other thing you can do is you can block traffic at two levels. You can block it right in the firewall. So if you want to block the traffic coming right in at the firewall at the sort of last point, you can do that in the 42Crunch firewall. But if you've got one IP address or one one attack surface that is hitting your APIs, it's probably doing other bad things in your environment. So what you could do is, and it's this question, you could feed that, sorry, wrong screen, you can feed that information back to your Azure instance. So in other words, if you're running on Azure, you can, and I know I meant to do this last time and I still didn't do it this time either, but quite easily within scripting within Azure, you can go and push that information to the API firewall. So if you're running or just even a network security group, and you can modify that rule and you can kick that IP address out for 6 hours, right? Then mark it as cleared, and if it comes back, then ban it. So you can defend at multiple levels, right? So you can allow, you can block explicitly, and you can do that both at the network layer and then at the API level at layer 7. So I hope that answers that. Microsoft are doing lots of, having just bought their share in OpenAI, they heavily invested into Azure machine learning. And, my caution for people that are considering other API platforms where perhaps they come with their own built-in machine learning or AI platforms, is that the right solution for you? How thorough and how good are those AI and machine learning? I would probably be staking my bets on Microsoft being able to do a pretty thorough job of that. And given that they also happen to be, they own the database of the largest number of threats in the world, they've got that continuous threat detection. I think the value proposition is pretty powerful. So benefits and advantages, and I cross-checked a lot of this with my colleagues and friends that work in SOC industries and SOAR, and they've said the idea of being able to cost reduce, so you don't have to go and buy a separate API monitoring tool, right? So you leverage what you've already got, you've already paid for. You're paying for your subscription to Azure. The difference in being able to store some more log space, it's incremental. You're not buying another complete platform and monitor and operate that. Accuracy, right? This comes as a benefit of the micro firewall being able to work at that layer 7. It knows what your API is, right? It has knowledge of things like your reset endpoint. It knows the HTTP error codes that are coming back, so it can be very precise. If you're monitoring web traffic and you're looking at logs, right, it's going to be very hard to find where's a failed API query in that, right? So it can be more accurate and more precise. Simplicity, the fact that the analysts work in their domain. They don't have to go and learn another tool, right? Your analysts all know how to write KQL queries. They know how to handle incidents. They know how to go and do IP address validation. So, rely on the fact that you're sticking to one platform. You can integrate it to other things, right? So your network security groups, your Azure Active Directory, and the fact that if you find an API that's vulnerable, you can actually disable the access to that API, right? So if you find something that's being mass exfiltrated, you can just step in and block access until you can. So we've got the recent news. I will answer that question on, can you please explain how rules engine is machine learning? No, it isn't. So those rules that I've written, the analytics rules, those are explicit rules that are, handcrafted, right? There's no learning involved there. Where the learning is coming in is in Microsoft being able to identify things like Tor nodes. It's being able to identify things that look like, for instance, if we were inspecting payloads, what Sentinel could do is it could go in and introspect and say, right, this looks like malware. It can do that, and it can try and infer that this range of IP addresses is a bot, right? So the analytics rules are very high level, right? And you need to interpret them. But if you're doing your threat hunting and your analysis and you discover that a particular IP address or range of IP addresses looks suspicious and looks like it's doing something, you can actually flag that, and then the algorithms will go and will try and go and correlate that. And they don't only correlate it on your instance, they correlate it across all of the Microsoft tenants. So that's the power of this, right? You're not getting your data being analyzed and trended and assessed. You're getting everybody who's using Microsoft. You're getting all of that data. fire up some of the questions we've got. We've still got a few minutes left, but just to highlight further resources on this, the API security.io newsletter that comes out every week. There's always something interesting. It's pretty busy at the moment. There's an absolute load of API attacks going on. And I've got a book coming out sometime 2023, I believe.
That's this year, right?
It is this year, yes. I may have said exactly the same thing on the previous webinar, but
Well,
there we are. Yeah, it's in progress. We have an API blueprint for success. This is something I've authored. It's helping organizations get to grips with API security, right? So where do they start? How do they build out a program, and how do they achieve success? And then upcoming events, we have a GitHub 42Crunch networking reception in Cloud Native Security Con that's next week. And then I'll be making hand-waving gestures on stage twice at Developer Week in San Francisco, middle of February. And there'll be virtual versions of that event as well. So if folk aren't over there, look forward to the virtual events. So thanks for your attendance. Good to see. Great questions. Thank you very much for your attendance. Great to show that, and glad to see all those questions. Thank you very much.